In this video lesson, we're going to be looking at imaginary and complex numbers. To understand why we call the square root of negative 49 7i, and why I squared is negative 1, or why 5i squared would be negative 25. Okay, let's start by taking a look at this table. This is the patterns of I. First, let's be sure we understand that the square root of negative 1 is what we call I. And we can also say, therefore, that I to the 1 power is equal to I. Okay? Now, I squared then will be made up of I times I, which is the square root of negative 1 times the square root of negative 1. And that, of course, equals negative 1. So we call I squared negative 1. And if we look at I to the third, well, that's made up of I squared times I. Well, the I squared would be negative 1 times the I, which is just I, and negative 1 times the I then is negative I. Then I to the fourth is made up of I squared times I squared. Well, that's negative 1 times negative 1, which equals 1. So we need to be familiar with this pattern. I to the 1 power is I squared is negative 1, I to the third is negative I, and I to the fourth is 1. Now let's consider these exponents. And I'm going to explain those here in a second. But you'll notice that these patterns are all multiples of 4, or not really multiples of 4, but 5, 9, 13, 17. We're adding 4 every time. The reason is because I to the 4 equals 1. So let me show you how I to the 4th equals 1 applies to our exponents. So if you take a look at the examples here, you can see that I to the 5th is made up of I to the 4th times I. Well, we know that I to the 4th is 1, so that makes this 1 times I, which is I. So I to the 5th, I to the 9th, I to the 13th is all going to be made up of a multiple of 4, and then I is going to be remaining. So the answer would be I. And if we look at this row here, I to the 6th and I to the 10th, well, the first one, I to the 6th, that's made up of I to the 4th times I squared. Well, again, the I to the 4th, it's kind of like that would cancel, and you would just be left with I squared, and I squared is negative 1. Well, all of these exponents would give you that same thing, because you would divide by 4 and be left with I squared. And then, of course, here's I to the third. Here you have, or if you had I to the 7th, that's made up of I to the 4th times I to the third. So when the 4th or the multiple of 4 cancels, you're just left with I to the third, or 1 times I to the third. Well, I to the third is negative I. So all of these exponents would give you an answer of negative I. And then I to the 8th is made up of I to the 4th times I to the 4th. Well, I to the 4th is 1, so that just says 1 times 1, so the answer is just 1, okay? So that's how all of these exponents would give you the answer I, or negative 1, or negative I, or 1. Okay, so in this first one here, we're going to evaluate I to the 9th times I to the 6th times I to the 8th. Well, when we multiply these, we just go ahead and add all of our exponents. Okay, so let's go ahead and add those exponents. And when you add those, we would end up with I to the 23rd, okay? Now, what I'm going to do is I'm going to divide this 23 by 4, or I'm going to break it down into, one way you could say that's made up of I to the 20th times I to the third, because this one equals 1. So you're multiplying 1 times I to the third. Well, we know that I to the third is negative I, so what you have is 1 times negative I. Well, a negative I times 1 is negative I. So your answer for this one is negative I. So this equals negative I. All right, next problem. Simplify the expression to A plus BI form, okay? So again, all of these have coefficients, but they also have these exponents. So the way that I'm going to solve this one is I'm just going to consider these exponents first, and I'm going to look for multiples of 4 and see what's left. Now, 60 is divisible by 4, so I know that this one basically says negative 9 times 1. Then we have minus, well, I to the 6th, if we divide by 4, we could say our remainder is I squared. All right. Then we're going to add 5. Okay, but then I to the 79th, when we divide that by 4, you're going to be left with I to the 3rd. And then finally, on this last one here, we have I to the 37th. When you divide that by 4, of course, 9 times 4 is 36. So you're going to be left with just I to the 1 power, or I. All right. So now we're evaluating. Obviously, this I to the 60th became 1. So our first one's just negative 9. Okay. And then minus, well, I squared is negative 1. So minus negative 1 would actually become plus 1. So again, minus negative 1 becomes plus 1. So I'm just going to write plus 1. And then we have plus 5 times I to the 3rd. Well, I to the 3rd is negative I. So we're going to call that minus 5I. And finally, in the last one here, we have plus I. So, of course, we just write plus I. So I'll put plus I right here. Okay. So then we work it out. Obviously, you see a negative 1, or I'm sorry, a negative 9 plus 1, which is negative 8. And then you have minus 5I plus 1I, which is a minus 4I. So negative 8 minus 4I would be our simplified expression in what we call A plus BI, A plus BI. All right, let's take a look at another. Okay, in this one here, we're going to write the square root of 125 in simplest form. Well, again, the square root of 125 would be made up of 25 times 5 times negative 1. Well, the square root of 25, of course, is 5. So 5 is going to come outside. And then the square root of negative 1 we call I. So we're going to write 5I. And then what's left is the square root of 5. So that will be our simplified answer there. 5I square root 5. All right, let's move on. So in order to simplify this expression, we have these square root symbols, or the radicals. So we need to consider the radicand. Now this first one, square root of 121. Well, that one's a perfect square. That's 11. So really that one's easy. That's just the negative 11. Because the square root of 21 is 11. Now this one, plus the square root of negative 54. Okay, well, we need to break that down into plus or minus the square root of, and I'm going to say negative, well, let's start with 9. Let's say 9 times 6, and then times negative 1. All right, then I'm going to keep going, plus the square root of 1, which is just 1. So the square root of 1 is just plus 1. And now minus the square root of negative 24. So let me keep working that out. Minus, and then the square root of negative 24. Let's break that down. So 24 would be 6 times 4, or I'm going to say 4 times 6, and then, of course, times negative 1, because it's a negative 24. All right, well, anytime you have this negative 1, you know that in your simplified answer, you're going to have I, because the square root of negative 1 is I. So you have one here and you have one here, okay? So if I keep working this down, I'm just going to bring down my negative 11 from the first term. And then the square root of negative 54. Well, the square root of 9 is 3. So 3 is going to come outside. And then the I is going to come outside. And what's going to be left is just the square root of 6. So I'm going to write this as plus 3I square root 6. Okay, and then I have my plus 1, which I just bring that one down. So plus 1 is here. And then minus the square root of, let's see, 4 times 6 times negative 1. Well, the square root of 4 is 2, so 2 will come outside. And then the square root of negative 1 is I. So that's going to be written as minus 2I square root 6. So I'm going to just highlight these terms here. We had, the first term was just negative 11, okay? And then the square root of negative 54 became this term. And then, of course, we had plus the square root of 1, which is that. And then finally, we had this minus the square root of negative 24, which became minus 2I to the 6th. Now we just need to combine everything. So you're looking for like terms, and our like terms are the negative 11 and the plus 1, which gives you negative 10. And then you have the plus 3I square root 6 minus 2I square root 6. Well, that would be, you would just be left with 1I square root 6, because 3 minus 2, 3I minus 2I is 1I, and then square root 6. So our final answer would be plus I square root 6. And that's how we would simplify that one. Another example. All right, this one we are going to multiply. So we have negative 9 square root 14 times 7 square root negative 2. So the first thing is we have the negative 9 times 7. Well, that's going to be negative 63. So we have negative 63. And then we have the square root of 14 times the square root of negative 2. So that's going to be the square root of negative 8. I'm sorry, negative 28. So now we need to consider this, the square root of negative 28, and what are the factors here. So we're going to say, I'm just going to continue simplifying that, or that'll be negative 63 times, and then we'll have 4 times 7 times negative 1. Well, obviously the square root of 4 is 2, so that's going to come out, and the square root of negative 1 is I. So we're going to have negative 63 times 2I square root 7. Because again, the square root of 4 is 2, square root of negative 1 is I, and then what's left is this 7. Well, now out here we have negative 63 times 2I. Well, negative 63 times 2I is going to be negative 126I square root 7. And that would be our final answer there. All right, in this final example, we have a binomial factor times another binomial factor. 3 plus 2I times 5 minus 4I. Well, we're going to FOIL it. Okay, so we have 3 times 5, which is 15. Then we have 3 times negative 4I, which is minus 12I. Then 2I times 5, that's plus 10I. And then we have 2I times negative 4I. Well, that's going to be minus 8I squared. It's I squared, of course, because we have I times I. Now we just need to combine what we can. We also need to evaluate this, negative 8 times I squared. Well, we know that I squared is negative 1. So really, this term is going to become plus 8. Because we have, this would be made up of negative 8 times negative 1, which is a plus 8. So really what we have is 15 minus 12I plus 10I plus 8. All right, so we have 15 plus 8, which is 23. And then we have minus 12i plus 10i. Well, that's minus 2i. So our final answer is 23 minus 2i. And that is a quick lesson on imaginary and complex numbers.